Hi, everyone. Thank you for being here in this session today. So we're going to talk about a new approach of artificial intelligence for fertility treatment, knowledge access, and decision-making. So this title was more directed actually to doctors, but yeah, the technique is more like about GraphRAG, and we're going to explore what is it in details. So to give a little bit more about myself, my name is Qais Hiwa, and on the past 10 years, I've been Chief Strategy and Innovation in one of the oldest and largest fertility hospital in Africa, based in Tunisia. And so I've been working in easing access to fertility treatments to tens of thousands of patients coming mainly from African countries. And in the past years, also providing trainings to hundreds of doctors coming also from African countries. And so based on this experience and also some background on computer science, so there is like actually 1 person over 6 over the world that is affected by infertility, and that is a big number. And all these people are affected by stress, stigma, mental illness, and also depression. And on the other side, a lot of persons lack awareness about fertility and reproductive medicine in general. And so we wanted to see how we can use generative AI in order to fill in a gap, either for patient education, access to accurate information on the medical side, and also help doctors analyze patient files and provide the right medical treatments protocols for their patients. And so this is when we started working at a very basic, I would say, RAG application in the past year, where we started collecting medical knowledge documents, on top of which we did like all the chunking work and also the vectorization and embedding. But it started like providing some interesting results, but it wasn't like quite accurate. And there was something missing, especially about filling this gap between like vectors and math, I would say, and then all the explainability of the medical like knowledge and medical sense of the semantics. And so then we thanks to I would say the Going Meta series, and I'm really thankful for all the work that has been done by Neo4j in order to try to democratize like information about GraphRAG. So the work done by Jesus, Alex, Thomas, and Daniel, we started like mixing up, getting from actually unstructured data to more structured knowledge graphs, and making all these medical papers, guidelines, structured in a very interesting and efficient new way. And so just like moving from vectors and only vectors in knowledge graphs, where we could actually build knowledge graphs and include inside of it a lot of interesting metadata that are connected to these research papers, such as like the titles, the DOIs, and also the different authors, the keywords that are used. And then for the text, we can also work on the full text and not just only the abstracts, and also extract the tables, on top of which actually we can do specific embeddings that are quite different from chunk embeddings, and also get the different references. And so now we have like a really better and interesting representation of a document, and more specifically a research paper. On the other hand, we could also like work on medical named entity recognition and actually include it inside the graph. And this is mainly based on medical ontologies, and I think there's been like tremendous work on the past like 20 years on building consensual medical ontologies that can be used by the different like medical experts on the sectors. And with the actual creation of the UMLS and the concept unique identifiers, we can actually now have a clear classification and also relationships between different ontologies. And this is thanks to a lot of work, including Stanford Center for the Biomedical Informatics and Research. And so now we can actually find inside all the different chunks what are the entities, but also their CUIs, their definitions, the semantic types, and then moving from one ontology to another. And so this is help us really add a medical logic to the documents on top of the vector stores and the semantics in order to reach consensus, explainability, and hopefully for the long-term precision. And so this is an example of how these NERs are performed. This is based on the SciSpaCy models, but there are plenty of others available. And so now we can actually start making the linking between the different papers because they share these entities. They also share keywords between different papers. Some authors might be authoring different papers also present in our knowledge base, and so on and so forth. And so now we are moving from actually 400 medical documents to 130,000 nodes and 1.6 million relationships. And so RAG, 400 documents and just a vector store, and then moving to all this, that's a bunch of structured data. And that can also provide to us interesting results. So even with a small data set of 400 medical documents, now moving to the evaluation. Unfortunately, we couldn't evaluate with a consensual data set because there is no consensual data set for evaluation in the reproductive care or the fertility, like the PubMed QA. So we created 180 yes/no questions that we derived from the master degrees at from medical schools. And then we actually found that, first of all, the GPT-4, when you ask it, more detailed and specialized, highly specialized questions, it performs a little bit less than when questioned into PubMed QA, even though the data set is very small here. But our model showed to be more precise in compared with all the different models. And adding a basic contextual query could, compared to a basic GraphRAG, could enhance the quality of the model. And so I think here, this is a very small prototype that we've done with a small size of documents. So I think that what we've been seeing in the past months with the GraphRAG for Python that is now available since some months now, we can enhance GraphRAG either with just a vector index or even contextualized query, and then we can have answers with more explainability, and that is something very important in the healthcare sector. So it's one of the top priorities to have it explainable as an answer, provide you sources, and also be able to minimize as much as possible the hallucination part. But still, I think the biggest challenges right now is, as I said, is about the evaluation of the models, especially that we are dealing with healthcare. I think the industry should move on to creating consensual or standardized testing models from a medical perspective in each medical specialty, and not just having general medical data sets to make Q&As and testings for the models. So that's number one. And I think number two, patient data privacy and security. With all these models that can be provided in chatbots, especially when it's multimodal, patients will be drag and dropping their medical files, medical reports, and we need to be very careful how these medical reports are interpreted, analyzed, de-identified and sometimes where the data is going to be stored. So I think there's like big challenges here to work on. So these are the kind of limitations, but I'm quite confident that a lot of interesting things will be happening in the coming months and years, and especially with this Nature paper that was published like almost like a year ago, more than a year, almost 2 years ago now. And this is like one of the largest knowledge graph in the healthcare sector. It's basically the ontology of the ontologies. And I think the mix of knowledge graphs, medical knowledge, patient data, medical ontologies, and generative AI will help us reach out precision medicine. In my case, maybe about reproductive medicine, but it's going to be for sure in many other disciplines. And so, yeah, thank you for your attention. Here are my contacts. So if you want to reach out, if you want to know more about like the startup we're working on with this technology, feel free to reach out. And I'm open to your questions. If there are any questions here now.